I worked on moving the Node code to Rust, and one interesting thing that I worked on was the node ID file. So in case you didn't know, the node, it creates a text file on its first start where it creates a node ID, and it uses this node ID in the network as a unique identifier for this node. And I ported that code to Rust. So let's open up that file, node ID. Here we are, node ID key file. So it creates the file on the first start, and from then on it only reads the node ID in subsequent starts, so that a node always has the same node ID. Node ID key file. And it is not much code really, so it checks if the file is already there, then it just loads the file, and if the file is not there, it just creates a one, okay? And I wrote unit tests for this, and this is now the interesting part, because I wanted to do this in the nullable fashion that I talk about so often. So that means I wanted to write the tests in a way that they don't actually write files and read files. But the tests, they should look like we work with real files. And that's what I did here. So let's first maybe look at the tests of the C++ code for this. So I've opened that up already here. And this is the only test. So there's just one test function for this, and it tests multiple things. And these tests are not that bad. But they work with the real file system, and that can have pitfalls. Not so much on Linux, but maybe on Windows, where I have had all kinds of strange test failures on Windows with virus scanners blocking files and other processes blocking files and whatnot. And yeah, so these are the tests here that we have in C++. And now let's switch to Rust and how I tested this code. So these are the tests. So in case you didn't know, in Rust, the tests are in the same file as the production code. These are the tests. And as you can see, I wrote a lot more tests than the C++ code has. And that is on purpose, because I am very pedantic when it comes to testing. And I like to test everything, like every single line, even the logging. And I know that this is an opinionated topic, because most people don't test logging. But I do test logging because I want to test everything that can go wrong. And log messages can go wrong. So I made that mistake a lot in my career, where I messed up the formatting strings, or I had a typo in the log message. And because I typed out these log messages twice, so I don't copy paste them, that reduces the typo probability, and also it catches the formatting errors, if there are any formatting errors in the code, in the logging code. So as you can see here, let's have a look at this test here. So it initializes the node ID file, and then it asserts that we have a log message. And the log message says reading node ID from and the path. So yeah, I do that. I actually test log messages. LFLF says, that's the first time I hear of log testing. Yeah, I know, not many people do it. And if it's okay, I mean, if it's okay if you don't do it, but I want to do it. I want to make sure that the log messages are correct. That's just, yeah, call me pedantic, but I am pedantic. Yeah, so in order for these tests to not use real files, I had to make the file system nullable. And that's exactly what I did here. So let's pick a test. Or let's have a look at the helper functions. I created a couple of helper functions here. For example, this one, initialize node ID with valid existing file. So what this helper function does is it creates a file, not a real file. In our nulled file system, it creates a file, and then it calls the initialization code. So let's have a look at the fs with key file function. And here it is. Here is the magic. I wrote this nullable file system struct. It is not much code really. I can open it up later, and we can just say that a path exists. So that means whenever we call path exists with this file path, it will say yes, true. And whenever we call read to string for this file path, it will return that content here. And that's it. That is the nullable file system. And we use this nullable file system in our production code. So this is the node ID key file. It gets in the constructor, it gets the nullable file system. And then it calls, yeah, file system exists here. And when it loads the key, it calls fs read to string. And these are just wrapper functions for the actual Rust functions that load files. Let's have a look at that. So this is the nullable file system. And read to string. Yeah, so there is two implementations inside of the nullable file system. We have the real one, so this is the real one. And as you can see, it just delegates to the real Rust functions. So read to string delegates to stdf, s read to string, create dir all delegates to, yeah, so this is just super simple, just delegating to the real functions. And then we have a file system stop implementation that just returns the configured responses. So as you can see, this is not much work to write, so just a couple of lines of code, but it enables us to test our code that works with files without having to actually use the file system. And those tests are super fast, and they are very reliable and easy to write. And I also tested the nullable file system itself. As you can see, when you scroll down here, I tested that the real implementation works, and this is the only place where I actually access the file system. So this is the only test here that actually writes files. Okay, so these two. So these are the tests for the real thing. And then we have the nullability tests here. Nullability, and they test that I can provide configured responses for all of those file system functions. Yeah, so that was the first thing I wanted to show you, the nullable file system and then the node ID key file code that uses it. And with this system, I could also write a lot of tests that are not in the C++ tests. For example, I have, the logging tests and also error cases. So here I test what happens if the file can't be read because of permission issues. What happens if the file can't be parsed because the file content is invalid. And yeah, also what if the directory can't be created. This test here fails if directory cannot be created. We can simulate those error cases easily, and you would have a hard time simulating those error conditions with a real file system. For example, this here says, so we say nullable file system null builder, and then we say create your all fails, and we give the path, and then we give the error. that we want to return whenever we call create dir all for this path. See, that's just really easy to do, and we can simulate all types of failure cases here. And it's, yeah, without accessing the file system. Isn't that fantastic?